Hi, this is Luke from the Stats Medic, and in this video we're going to talk about significance tests for a mean. This is day 2, and we are going to do that using the activity, what is normal body temperature? So we have 2 learning targets that we want to try to address here. The first one is to perform a full significance test about a population mean using the 4-step process. And then second, we want to understand the connection between confidence intervals and significance tests. So let's take a look at the activity. It says here, what is normal body temperature? For many years, doctors have told people that normal body temperature is 98.6 degrees Fahrenheit. Today, we will try to find out if this is true. So if we were in class, we would take the body temperature of each one of the students and record it at the front of the board, and then find the mean and the standard deviation. So I'm actually going to take some data from one of my class periods and give that to you so that we have some numbers to work with here. So you see where it says X bar, the average from that particular class was 98.237. The standard deviation was 0.822, and that was a class of 32 students. And so based on that average there, 98.237, we certainly have some evidence that normal body temperature has changed from 98.6. But the question is, do we have convincing evidence? Is this value far enough away that it is statistically significant? And of course, in order to answer that question, we need a significance test. So you are going to do a full 4-step significance test. And then there are a couple of follow-up questions in the bottom of the activity here. But I'd like you to try all those questions on your own first, and then come back here to check your answers. So you can pause the video now. Let's see how you did on the activity. For the state, you want to start with your parameter here and making sure that we're referring to the population. So we're using the word true, mean body temperature for all high school students here. Remember, we're thinking of these 32 students as being an SRS of all high school students. Well, we know our statistic is the mean from the sample of 32 students. The null hypothesis here would be that the doctor's claim of 98.6 is correct. And then for the alternative, we had to decide whether it's one-sided or two-sided. And you'll notice here that we've made this a two-sided test. And that is always depending on the wording of the question here. And so you'll see it says, do the data provide convincing evidence that the mean body temperature is different? So we don't know whether it's above 98.6 or below 98.6, which means we need a two-sided test here. So we used does not equal, and then we're going to use an alpha level of 0.05. So the name of this procedure, it is one sample of 32 students. We are using T here rather than Z because we're dealing with means. This is a test rather than an interval, and it is for mu. Now, the general formula is always going to look the same for any significance test or most significance tests. And that formula is actually given to you on the AP exam. The specific formula here is for the T test statistic. We just take our statistic minus our parameter all over the standard error there. And then we plug in the numbers and we get a T test statistic of negative 2.50. So that means that we are 2.5 standard errors below the mean, which would lead us to believe that the p-value is going to be fairly small here. So you'll see in our picture here, the mean is 98.6. That's our null hypothesis. And then here is our statistic, 98.237. And you'll notice, because this is two-sided, we had to make sure that we shaded on both sides of the normal distribution here. And I just calculated this value to be the same distance from 98.6 as our statistic. So let's make sure that we highlight the t-test statistic here. And then you can use TCDF on your calculator or just do the t-test on your calculator in order to get the p-value. The area on the left is 0.009. Of course, we have to double it because it's two-sided. And we end up with a p-value of 0.018. And so we are now ready to make a conclusion. Remember, the first sentence in your conclusion is always where you are going to interpret the p-value. And so interpreting the p-value amounts to describing this shaded area that you see in your picture. So assuming the null is true, that the true mean is 98.6, there is a 0.018, there's your p-value, probability of getting an x bar of 98.237 or lower, or on the other side, 98.963 or higher, purely by chance. Okay, then down here, we are going to make our decision to reject the null or fail to reject the null. And then we're going to make our final conclusion in the context of the problem, specifically about the alternative hypothesis. So because that p-value is less than our alpha, we are going to reject the null hypothesis. And we do have convincing evidence that the mean body temperature is different than the doctor's claim. Now, in terms of the wording for the final conclusion there, you can see we said convincing evidence that the mean body temperature is different than the doctor's claim. You will notice that that is actually stolen right from the question here. The question says, does this provide convincing evidence that the mean body temperature is different than the doctor's claim? So we've just taken those words and brought them right down into that conclusion there. Now let's check out the second part of the activity here, where you were given some class data from a different class. So they have a new statistic now of 97.9, new standard deviation, and this was a class of 30. And you used your calculator in order to find the p-value there. And we got a pretty small p-value of 0.023. And so now based on that p-value, we had to make a decision about the null hypothesis. And so at the 10% level, our p-value is less than 10%. So yes, we would reject the null hypothesis. At the 5% level, our p-value is still smaller than 5%. So yes, we would reject the null hypothesis. But when we get to the alpha level of 0.01 or 1%, now our p-value is greater than alpha. And so we would fail to reject the null hypothesis. Next, in number 2, you had to create a confidence interval at several different confidence levels. And so you can see those confidence intervals given there. But then based on those confidence intervals, we had to make a decision about the null hypothesis. And so at the 90% level, we wanted to decide if we should reject the null. Well, remember the null was 98.6. And if you look at this interval, 98.6 is not contained within that interval. And so it is not a plausible value, and therefore we would reject the null hypothesis. Now we move to the 95%, and once again, we're looking for the null hypothesis value of 98.6, and still it is not a wide enough interval in order to contain 98.6. So once again, we are going to reject the null hypothesis. But when we get over to the 99% confidence interval and we look for that null hypothesis value of 98.6, sure enough, this time it is contained within the interval and is therefore a plausible value, and we would fail to reject the null hypothesis. Now for number 3, what connection do you notice between your answers for number 1 and number 2? Well, I was hoping that you noticed that your decision with the significance test is the same as your decision using the confidence interval here. You are always going to make the same decision. But what's the connection between the significance test and the confidence interval? Well, take a look. When you have an alpha level of 0.10, that corresponds to a confidence level of 90%. 5%, 95%, 1%, 99%. So very clearly you can see there's a relationship here that the significance level is the complement of the confidence level. So out in the margin here, let's just make a note to ourselves that the alpha level is just equal to 1 minus whatever your confidence percent is. Now, very important here, this only works for a two-sided significance test. So when we say we get the same results here, let's make a note that this must be a two-sided test. Confidence intervals are essentially two-sided. So if you're going to try and make the connection between significance tests and confidence intervals, you have to be using a two-sided significance test. So let's go ahead and summarize in the important ideas. let's start by checking back to the learning targets from the beginning of the lesson. So the first learning target was about doing a full significance test for a mean using the 4-step process. So let's just make sure that we know what must be included in each one of the steps in the 4-step process here. So the first step is the state. And here is a list of the things that you need to make sure you include in the state. You want to have your parameter. You want to have your hypotheses. You want to have your statistic. And you want to have your significance level alpha. In the plan, two big parts to the plan. First, you need to name the procedure. And then you have to check the conditions. We didn't have to in the activity today because it said assume the conditions are met, but generally you're going to have to check your 3 conditions here, which remember is the random condition, the 10% condition if you are sampling without replacement, and then the normal large sample condition. All right, the third step is where we actually do the calculations here. So you want to make sure that you start with your general formula, then you have your specific formula, then you show your work, including a picture. And then of course, the important thing is your test statistic and your p-value. And then the final step here is the conclusion. And hopefully at this point, you're getting fairly comfortable with your conclusion. You want to start by interpreting the p-value. And then your second sentence, you're going to make a decision, followed by a conclusion about the alternative hypothesis. So that takes care of the first learning target. Let's take a look at the second learning target. This is where we made the connection between our previous work with confidence intervals and the more recent work with significance tests here. So learning target number 2, we're going to be making the connection between confidence intervals and I'm going to make it very specific here, 2-sided tests. We said that it had to be a 2-sided test, not a 1-sided test. So here's the deal. When you're looking at your confidence interval, and if you're making a decision based on the confidence interval, there's 2 possibilities. If the null hypothesis value is in the interval, well, then we think that it's a plausible, the null hypothesis is a plausible value, and we're going to fail to reject the null hypothesis. And that's because we think that the H null value is plausible. It's one of the plausible values in the confidence interval. Now, the other possibility, of course, is that if that null hypothesis value is not in the interval, well, now we don't think that the null hypothesis value is plausible, and we are going to reject the null hypothesis. And that's because the null hypothesis value is not a plausible value within the interval. Now, what we discovered, here's the connection, all right, between a confidence interval and a significance test. If you have a C% confidence interval, okay, that could be 90, could be 95, could be 99. We found out that it will make the same decision. So either to reject the null or fail to reject the null, as if you did a 2-sided significance test. And the connection here is the alpha level for your significance test. The alpha level would be 1 minus the C% confidence level. So let's go ahead and see if you can apply your new learning in the check your understanding problem here. There are 2 questions. So go ahead and try those 2 questions. questions on your own, and then you can come back here to check your answers. Let's see how you did on the check your understanding problem. For number one, we had to write our hypotheses, making sure that we defined our parameter here. The null hypothesis is going to be the claim that the company is making, which is that the average flight time is 32 hours for these helium balloons. For the alternative, we had to decide whether it is one-sided or two-sided. And you'll notice here that we've decided to go two-sided here, not equal to, and that's based on the wording of the question. There's one word that gives it away here, and that is differs. And then we had to define our parameter mu, making sure that we're referring to the population here by using the word true and the word all for the parameter. Now for number two, they gave us the confidence interval here, and notice it's a 95% confidence interval, and asked us to make a decision based on the confidence interval. And we know our null hypothesis value is 32, so we're looking for that value within the interval. Now 28.5 to 31.4 does not contain that 32, so we do not think it is a plausible value, and therefore we would reject the null hypothesis. Now make sure that you note the connection between the confidence level and the alpha level, right? Those are complements of each other there. And even a little bit more so, if we know that we're rejecting the null hypothesis at alpha equals 0.05, that actually does tell us something about the p-value without us having to calculate it. If we're rejecting the null at 0.05, we actually know for sure that that p-value is going to be less than 5%. So this concludes the video for significance tests for mean, day 2. Thanks for watching.